Morning, everybody. I'm Bernadette Fritsch from Alfred Wegener Institute for Polar and Marine Research. I hope you all enjoyed the evening last in the wine cellar with the delicious food and drinks, the wines. And I think the local team earns applause for that nice evening. Now I have the pleasure to introduce Dagmar Krefting. Dagmar is professor at University in Göttingen and director of the Institute for Medical Informatics at the University Medical Center Göttingen. Before she joined her current position, she was at HTV professor and was engaged in the diversity in computing science by setting up a women's study program. First time we met years ago, it was in
about 20 years ago.
It was in projects where we aimed to build up collaborative research environments for our corresponding communities. Differences between our communities are, for instance, and now Dagmar will talk about in innovation and regulation requirements on research software in the biomedical domain. Thank you for coming.
Yeah, thank you, Bernadette, for the kind introduction. I'm very happy to be here. I missed the latest Research Software Engineering Conference, but I attended in Potsdam 2019. I'm impressed how far this field went, and in between I switched my position, and now before I also did research software in biomedical in the biomedical domain, but now being on a university medical center makes things really different. So my first question to you, just to get you up, so who knows the name of the data protection officer of your institution? Excellent, you're very well informed. And who of you have ever signed a data protection policy? This is very few, so I assume the others are not working or developing research software in the biomedical domain. So this is nothing new for you, the research software process and its infrastructure, but I like the picture. So you see, we come from information, we have methods, analysis, and transform that to knowledge. And the research software, research infrastructure is composed in different components: research data, analysis software, the execution environment, and finally the research results. And obviously, the analysis software is research software. I think that's what we agree. Everyone agrees on that. But we, at least in our realm, the research data management software is also a super important part of research software. And of course, the research software environment software is also research software. And last but not least, we also have research software to generate the data. So everything's research software, and that reminded me to the old German speech. If you have a hammer, everything looks like a nail. The question is it, yeah, so if you're a research software engineer, everything looks like research software. And I very much liked the statement from the Research Software Encyclopedia that formulated these questions. Probably you discussed that already in the conference already. And so for most of the topics, questions, we can easily answer yes. And in the biomedical domain, the main question is it really created with the intention to be used on research, right? Because this is, so when I talk about regulations, about medical device regulations, you may think of, okay, that might not be part of research software, but might be part of more like the commercialization of medical healthcare. But this is not the case, which I want to show you in the next, in this talk. So we have a huge bunch of different medical research. I'm sorry for the quite bad resolution of this image. And so from basic research to, and this is the part I will talk today about, is the research here, clinical research and epidemiological research, where basically most of the studies are conducted, from clinical trials to observational studies, population studies, and this always involves humans. So this research always involves humans, and most of the time, patients. And then we're in the middle of the General Data Protection Regulation, Article 9. So this is our main concern, processing of genetic data, biometric data, and the purpose of, or it seems to be that this computer has a different font set than mine, so I'm sorry for the ugly font. That's always the problem if you switch. So platform independency is not always given. So processing of genetic data, biometric data for the purpose of uniquely identifying a natural and data concerning health, among others, shall be prohibited. So shall not be processed. So that's the problem we have to face. And of course, we couldn't do any research if there wouldn't be any exceptions. So the exception is if the data subject gives explicit consent to process the data. There are some exceptions, so state laws may prohibit the processing anyhow, even if the person gave explicit consent, but in general, this is what we use, so that's really ugly, I'm sorry for that. And then an important aspect is, when we look into the European regulations, that there is a part that specifically addresses the processing of health data, or sensitive data, that's a general term for it, that the state members may maintain or introduce further conditions, including limitations, with regard to processing data concerning health. And this is formulated in the German Federal Data Protection Act, Bundesdatenschutzgesetz, BDSG. So, and this is an extremely important aspect. So we think we are in the European Union, so we all have the same GDPR regulations, but it's not the case. So the member states may specifically for these sensitive data formulate their own regulation, and it's very unusual that they can set limitations. So that's the only part, to my knowledge, where they can actually limit further the use. And so the German Data Protection Act says that there is a possibility in Section 27 that you can actually perform research without consent if this is really necessary for the purposes and the interests are substantially overweight those of the data subject in not processing the data. Could you imagine any research where this would be valid? So where would that be overweight? Any ideas? Exactly, yeah. COVID is exactly such a case, because it's a very strong bias in people who consent the processing of the data. This is what we saw in the hospital, so it would completely bias the data, and that was one reason. Anyhow, COVID was also part of the infection law. That's another exception. So what does it mean for us? It's also specifically written down in the Bundesdatenschutzgesetz that we have to take appropriate and specific measures to safeguard the interests of the data subject. And among these, specifically restrictions on access to personal data, pseudonymization of data, encryption of personal data, and ensuring confidentiality and integrity among others. So availability is in research probably not that important, but so we are kind of bound by this legal restrictions, what we can do with the data. And so a typical step you always have to do if you want to do research with, in the biomedical domain is that you need to write your research project, and then you have a study design that you will discuss with the ethics committee, that you would need a positive vote from. And an important part of that is that you have to do a privacy impact assessment, and then you have to write a data protection concept. And this is typically supervised by or evaluated by the data protection officer. And when the data protection officer says, okay, that's okay, then you may perform your research. A further exception is that if the data is really anonymized, so if you use an open database, for example, the health data, this is not a part here. But most of the data, and that's a constant, let's say, a challenge, most of the data is stored and maintained pseudonymized. And the reason actually for that is that data subjects have the right, according to the GDPR, sorry for being a bit formal here, to withdraw the consent. So you have the right to withdraw your consent. You can at any point, you can say, okay, I gave my consent, but I want to withdraw it. So if you anonymize the data, you can no longer withdraw your data. So this is a constant challenge discussing with the data protection officers, which is overweighting here the right to withdraw or the possibility to use the data widely. Well, we're not talking so much about data today, but about research software. And so what you need to do if you write your data protection concept, if you are in the realm of clinical trials and good clinical, then you're under another regulation. It's called good clinical practice. And then you need, you're only allowed to use validated software, research software. If you are in the part of the data collection, so if you're building data management systems, as long as it's just documentation, you're kind of fine, so you have no further specific regulations, but you need to describe your technical and organizational measures. If you, and this is something we suffered a lot from because we wanted to perform a study with wearables. And because this is processing, and it's not just data collection, we were forced by the ethics committee to certify it as a medical device. So then the medical device regulation jumps in. So everything where anything is processed, right? Every AI algorithm, any analysis algorithm that you actually want to use in such studies would be a medical device, would fall under the medical device regulation. You have to define your data. So if you are in a research infrastructure and a collaborative research infrastructure, as Bernadette already introduced, then you typically would also transfer data. And then you need to write your data flow diagram and need to describe your technical organizational measures. And last but not least, for the data analysis, the same holds. And the problem, what we face is that the description of the TOMs, they're called technical organizational measures, very much depends on your local data protection officer. So what I didn't mention already, we have the Bundesdatenschutzgesetz, but in Germany, data protection is, so for data protection, the individual states are responsible, so we have 16 different data protection laws. And they are not, it's really impressive, right, that my data in Bavaria is considered other differently than like in Lower Saxony, but that's a fact. So I want to give you an example. For example, the Medical Informatics Initiative. Anyone knowing the medical? At least some, so I give you a very short, brief introduction in that. It started 2016, and it's meant to get the data from the hospital information systems to enable big data analysis and analytics and big data methods based on this like clinical routine data. All 36 German university medical centers take part. It's about 10% of all hospital submissions are covered with that, so that's quite a number. And every university medical center has a data integration center that extracts and transforms standardized data model, and is part of this network, which is, so the data is held locally, and there is a common and central portal to Science Gateway, probably we would tell it here, the Forschungsdatenportal, where you can search for the data and where you can, so you cannot access the data, but you can search the data and write your application through that. And the software is quite complex. I hope it's barely seen. So this is the local part. So this is times 36, and this is the central part. And here, different open source tools developed by different groups are involved, at least 4 different parts. And what we also face, and I think it's not very new for you, that it's often small groups that develop very critical and important research software. So most of the groups, it's basically 1 or 2 developers. And what we also see is that in the biomedical domain, open source is not super widely known, let's say. So it's impressive how many concerns that have long been discussed and found not relevant are still there. But at least, so we do have different open source software here, so times are changing. But if you build such an infrastructure with a publicly available portal, of course you're under surveillance. So it's not, so to show you, it's not just theory, that you have to do all this very boring work on the data protection, privacy assessment. You're really under surveillance, and you all know, are probably part of groups who are really, I think it's super important, like to have groups who look into data protection, but typically, and what I find in that case a bit annoying, is that they don't come to you and say, we see a problem probably, but just go to the press and then make a big fuss of, probably it's not everything correct. Anyhow, it was everything correct, but so we had a Heise article just 2 days later. Have they done the privacy impact assessment right? So so you really like it's doing this. It's all research software. It's all built in projects, right? But you have to prove. You have to maintain the data as any other data that is that's processing personal data. So this just as an anecdote. Of course, you will surely discuss here also artificial intelligence. And this is an important aspect in research, in biomedical research, as in any other field in the moment. And this is actually why we try to get the data together. And if you want to do it, so of course you can do it on your open data, publish in a publication or in a journal, and that's it. So, but if you want to have impact, and this is actually the only thing, in my opinion, why people are staying in the university, in the academics, and are not going to industry, is that they want to have impact, and that they want to help people, and that they want to improve the health system. So if you really want to do that, you need to think about the translation into practice, and not just after your publication, but you have to think from the beginning on, because you want to validate your method. So if you develop a cool method, you want to validate it. So then you need to at least consider that your software will be a medical device. So there's no way out. That it will be a software on high risk according to the AI Act. So every medical device is considered as high risk, and that you have fulfilled the Cyber Resilience Act, and that you have to prove and certify your software. So that's loads of things, and it looks probably a bit discouraging, but we do have a proper community that's organized. It's called, let's say, biomedical research networks are organized in the TMF, Technology and Methods Platform for Network Medical Research, as an association for regional and cross-regional research networks and institutions in the field of medicine. And we have established a few working groups there that actually help you to do it and to go through that path. So it's the data protection working group. I think it's the oldest group. It already existed in 20 years ago, that helps you actually to write your data protection concepts. They would even give you a vote, and if you get a positive vote, then generally it's very easy to go through the different data protection offices. We do have a working group, IT infrastructure and quality management, that hosts also a repository for research software and common tools for biomedical research software infrastructure, and a very new working group, as I hope I have shown you, which is very important, is the group for medical software and medical device regulations. It was founded last year, and it supports or tries to support you in all these aspects, in how to organize your software, how to build your quality management infrastructure. So that's the good message. So you're not alone with that. I'm much faster than I thought. Well, that might not be better than the other way around. So the conclusion would be biomedical research software is embedded in a complex regulatory context due to the research with sensitive data. So we do have different formal inspections and audits that are required to run the software, to bring that actually into practice. And what is another aspect that we now face is that if you're under all these regulations, and you are part of the university or university medical center, which is quite huge and has a huge budget, let's say. And as you may know, the data protection breaches, so the maximum fine you could get depends, I think it's 4% of your budget, right? So, and they start to get nervous if you want to bring your research software into practice. So the question of liability for specifically in data leaks, that's a major concern we currently face. So if we want to build these infrastructures. But as I mentioned before, you're not alone, and together we will face this. Anyhow, we don't have any other option, right? Because we need to we need to progress in biomedical research. So as a biomedical research software engineer, you spend loads of time to fulfill this regulatory requirements. You have, as I have shown you, hopefully shown you in the example of the Medical Informatics Initiative, so your software is used by the whole national infrastructure. So you have a high responsibility to sustain and maintain the software as part, if it's part of an integrated infrastructure, which is kind of high burden, right? If you are the only developer on that and decide, probably I would like to do other things in my life, I would leave university, so that's really an important question. So how to guarantee sustainability? This is a current, let's say, important issue that we discuss in all the different groups, is how can we develop operator models to maintain such software with limited liability, but sustainably. And with that, I thank you for your attention. Forward to questions. I see a question.